Hello. Presently, I will discuss about Poisson's distribution. तो Poisson's distribution के बारे में हम डिस्कशन करेंगे, and that is Poisson's distribution. So first of all, we know what is the Poisson's distribution. The that is one of the discrete distribution. Poisson's distribution is a discrete distribution problem. It is a discrete. Discrete distribution problem, and probability function for this Poisson distribution is defined here, and fx. Fx is the probability function, and which is represented here mu to the power x e to the power minus mu divided by x factorial. X is equal to 0, 1, 2, 3, dot. So this represents as the Poisson's distributions functions, where mu is represented as the mean of the functions. The mean binomial distribution is mean here. This is mean of the binomial distribution, and that is also considered for the mean for Poisson's distribution. And the variance is also mean. The variance is also mean of this binomial, this Poisson's distribution problem. So basically, we have to compute here the Poisson distribution by using the mean of the given problem, and mean of the given problem is that is also purely based on success and failure of the problem, or effective or non-effective, defective or non-defective of the problem. So just one example we have to consider for this problem. One example, how to solve, how to use this problem. If the probability of producing defective skew, if the probability of defective skews say that P is equal to 0.01, that is defective skews you have to find it. What is the probability that a lot of 100 skews? What is the probability that? What is the probability that a lot of 100 skews? So just we know 100 skews means that is n is equal to 100. Represent here n is equal to 100. P is equal to this value means q is represented here 1 minus 0.201, and that is equal to 0.99. That is q, and n has represented of the 100. So by using the binomial distribution, no, by using the Poisson's distribution. For the case of Poisson's distribution, whenever you look out our calculation procedure or model part of this problem, is basically mu is considered, and mu is calculated as the mean of the function. So first of all, you calculate mean is equal to n into p, and that is n is 100 into 0.01, that is equal to 1. The mean is equal to 1 is there. So probability distribution function is calculation by using the mean, and that is mean has already 1. The question is that more than 2 will be defective. We need to find the probability of this function more than 2 will be defective. Probability we need to find more than 2 will be defective. More than 2 will be defective, not including 2 or including 2, not including 2. More than 2 will be defective. That means whenever we look out this problem, More than 2 means 0, 1, 2, 3, 4, up to n times. 100 times is there. More than 2 will be defective. That means not including 2. More than 2 means this will be defective. 3 to 100. So this one is non-defective. So P plus Q, we have known that P plus Q is equal to 1 according to the condition of the probability. If we need to find the probability of 3 points and subtract from this 1, so Q is equal to 1 minus P. But we need to evaluate the more than 2 will be defective, means we need to evaluate the probability of these all these value and add together. Otherwise, we can say also 1 minus probability of 0 plus probability of 1 plus probability of 2. We can evaluate this function by using the probability distribution functions or mean of the given function. F0, F1, F2, we can evaluate this value. So we know that one formula is fx. What is fx? Mu to the power x e to the power minus mu by x factorial. So we can evaluate f0 e to the power minus mu, f0 e mu to the power 0, mean is 1 e to the power minus 1. That is 1 by e. F1 mu e to the power minus mu divided by 1 factorial. F2 mu squares, mu is 1 has already given, this is 1, this value is evaluated 1, mean is evaluated 1, that is only for the e to the minus 1. This is 1, e to the power 0, that is mu is 1, 0, that is e to the minus 1, e to the minus 1 by 1 factorial. F2 also 1 e to the minus 2 by 2 factorial. So all this value put in this equation, then we have to evaluate here 1 minus probability x greater than 2. We can evaluate it here. Probability x greater than 2. That is 1 minus 1 by e plus 1 by e plus 1 by 2e, and that value is becomes 0.0794. So this is the case of the Poisson's distribution. Why Poisson's distribution is utilized for application, and what is the application of Poisson's distribution? What is the main applications of Poisson distribution of this function? So we just basically consider for the application of this function. The applications of the function is that demand patterns for a certain spare parts, number of fragments from a cell hitting target, special distribution bomb yields. That is case for the applications in this case. So this is the case of the binomial distribution problem, a Poisson's distribution problem. We have to solve this problem. Okay, thank you. We'll discuss next.